instead of dividing the set of real numbers into rational and irrational numbers, we could have chopped it up in a different way. For example, we could have created a subset called R minus, which would be the real numbers that are negative. We could have created another subset, called it R plus, which would have been the positive real numbers. And then there would have been a third subset having only the element 0 in it. So R minus is a subset of R plus is also a subset of R, and the singleton set having only the number 0 is also a subset of R. In fact, every real number has to belong to one of these three subsets of R. There is also no overlap between these three sets. They are completely disjoint, which means they share no element in common. Now here's a slightly different way of dividing up R. We could have created a subset of R corresponding to all real numbers having values less than a. So let me call this subset as the set of all numbers x, such that x is less than some fixed number a. Then we could have created another subset of R having numbers whose values are greater than b, where b is again some fixed number. And so the third subset would have consisted of those numbers whose values are greater than or equal to a and less than or equal to b. Obviously, I'm assuming here that a is less than b. So if we represent this on the number line, we could have a somewhere over here and maybe b somewhere over here. B is greater than a. And so this left subset over here would be the set of points lying to the left of point a along the number line all the way up to minus infinity. The right subset here would correspond to all the real numbers along the number line which have values greater than b, and the third subset here would correspond to all the points from a to b along the number line, including a and b.